So this video kind of introduces you into something called the chain rule. Okay, but first of all, we're gonna kind of show you why chain rule works, like where it comes from. So we've got y equals brackets 3x plus 4 all squared. So currently, how would we differentiate it? Well, what we would do, so we've got y equals square brackets 3x plus 4. Squared means we've got two sets of the same bracket. Okay, we would expand, so 3x times 3x is 9x squared. 4 lots of 3x, add 4 lots of 3x is 24x. Add 4 times 4 is 16. So we'd expand out the brackets first of all. Then we would differentiate. Okay, so 9 times the 2 is 18. X, take 1 from the power. Plus 24 times the power is just 24. If we take 1 away from that power, it becomes power 0, which is just 1. So that's what we get, is 18x plus 24. Well, I can factorise that. So I can take 6 outside the brackets. So 6 lots of 3x plus 4. Okay, so that's currently how we would do that set of brackets. Thinking about this one. So currently, how would we differentiate this? Well, we do exactly the same. So we've got y equals squared means same set of brackets. So x to the power of 4, take 3, brackets x to the power of 4, take 3. Okay, so x to the power of 4 times x to the power of 4 is x to the power of 8. Take away 3x to the 4, take another 3x to the 4, so take away 6x to the 4. Negative 3 times negative 3 is plus 9. Okay, so we want to try and factorise, we want to differentiate this first. Okay, so our differential would be, well, this is an imaginary 1 before the x to the power of 8, so it would be 8x to the power of 7. Take away 6 times the 4 is 24. X, take 1 from the power, is 3. And the plus 9 would disappear. But we want to try and factorise this. So we would end up with 8x to the 3, brackets x to the power of 4, take away 3, close brackets. Okay, so that's what we would end up with. So now we're going to look at kind of what we got. So the first question, we had y equals 3x plus 4 all squared, and our differential ended up being 6 lots of 3x plus 4. Our second question was this, and our differential ended up being that. Okay, so I'm hoping that we can kind of notice at least something from our original y to our differential. Okay, but if we kind of look a bit closer, that is the same as 2 times 3 times 3x plus 4, and that is the same as 2 times 4x cubed, brackets x to the power of 4, take 3. Okay, so I'm hoping that we're even kind of noticing more things now I've written it that way. So we can see that we've got a 2 at the beginning because originally they both had a power of 2. Okay, this 3 has come from the differential of my bracket. So if you differentiate 3x plus 4, we get 3. So this is the differential of the bracket. Okay, and we can notice that that's exactly the same here. If you differentiate x to the power of 4, take 3, you get 4x cubed, which is there. So that's the differential of the bracket. Okay, then we have obviously the actual bracket itself, but the power is now 1. So we've still taken away 1 from the power. So we've still taken away 1 from the power. Okay, so now we're going to have a look at this question. So this is obviously to the power of 5, so I don't really want to be kind of expanding these brackets. I'm going to be there for ages. Okay, so we want to try and start to use chain rule. So remember, we've got y equals 3x take 1 to the power of 5. So my differential would be, I times by the power, so it would be 5 times, what's my differential of inside the brackets? Well, if I differentiate 3x take 1, I get just 3. Then I multiply by the actual bracket, and I take 1 from the power, which is 4. Okay, so my differential is 15 times 3x take 1, all to the power of 4. Okay, this is not how you would present your work. This is just kind of showing you kind of what happens when we use chain rule. The next video will talk you through a formal example on how to set out your work, so please make sure you watch the next one and make some notes.